Hi guys, welcome to Bitworld. Today we'll be going through dynamic programming problems. So here is a very simple dynamic programming problem, that is Fibonacci series. Okay, so as you know, Fibonacci series is something like this. Okay, where the first element is 0 and the second one is 1 and the third one is the sum of this and this. Okay, that is 0 plus 1, and then the next element is sum of this and this. Okay, in the very same way 3 is sum of 1 and 2. Okay, so likewise the number at I plus 1 location is sum of number at I and I minus 1. Okay, the concept of dynamic programming is that we have to find an optimal solutions to a smaller problem to give an optimal solution to the larger problem. Okay, so actually this problem can be converted into smaller problem. Okay, first let's calculate the sum of 0 and 1. Let's store this sum, then while calculating the sum of 1 and 1, we'll use the sum of these two numbers. Okay, so this is the concept of dynamic programming. So basically in dynamic programming we have to find if there is an overlapping sub problem or find if there are optimal substructure. Okay, so if you see, while calculation of 0 1, we have got the sum as 1. Okay, but for the calculation of the other sum, that is 2, we have to take these two numbers into consideration. So you can see 0 and 1 and 1 and 1. So you can see this 1 is overlapping in the calculation of 2. So basically we should store 1 in some variable and store the sum of these two numbers. That can be useful for finding the sum of these two numbers. Okay, so let's see how I have implemented the code. So this is the main function. Okay, so I'm calculating the Fibonacci of 10, f of 10. Okay, so let's see if you the constraints over here is that if n is negative, that is n is the if n is negative, so in that case we have to print the negative numbers are not allowed. Okay, we have to start with 0. That in Fibonacci series we really don't entertain the negative numbers. Okay, then now if n is equals to 0, that is 0. Okay, or n is equals to 1, there is only 1, so then we will return n. Now let's go to this case. We have 0 and 1, so we have 0 and 1 in the form of a and b. Okay, so a is equals to 0 and b is equals to 1. Okay, so since we are already done with these two numbers, okay, then what we'll do is we'll start our for loop from here till n plus 1. Since you know that in case of list the index starts with 0, so we have to traverse from 2 to n plus 1. So for I in range of 2 to n plus 1, c is equals to a plus b. That will give me the sum, that is 0 and 1, 0 plus 1, that will be 1. Okay, here now c is having the sum as 1. Okay, now what I'll do is, like I said before, while calculation of 0 plus 1, the sum is 1. While calculation of 2, the numbers are 1 and 1. So here the number 1 is overlapping, so I'm storing this number 1 in a, and the sum which we have actually found in b. Okay, this is very logical. Okay, a is equals to, so for the first case the sum would be 1. Okay, and a would be 1 and the sum would be 1. Okay, so b would be 1. Now when the loop will iterate, then in that case a will be 1 and b will automatically will be 1. Okay, so here what we are doing is we are taking the calculated sum which is getting overlapped, okay, and the overlapping number, that is 1, in a separate variable, and we are returning the result. So basically, if you see a very basic solution to this Fibonacci series using recursion, the complexity of it is in exponential, but basically using DP we are actually having complexity of big O of n square, which is actually a polynomial complexity, and which actually assures a much faster running times than other techniques like backtracking, recursion, etc. Thank you. And let's run the result. So run. Okay, so you can see the for the Fibonacci series for 10, the sum, the calculation is 55, as you can see over here. Okay, so 1 2 3 4 5 6 7 8 9 10. Okay, the next is 55. This is how it is. This is from my side. Thank you.